Hello everyone, I'm Miss Betsy and I'm very glad that you have joined us today for your very first class in Algebra 1. Let's go ahead and begin our session with prayer and then I'll tell you a little bit about the course, okay? Father God, I thank you for your goodness to us and I'm grateful for these minds that you have given to us and the ability that you've given to us to understand mathematics and to learn more about this world that you've created. Father, I ask that from the beginning of this class on throughout the year, Lord, that you would give to me the ability to communicate this subject matter to my students in a way that they're able to understand. Father God, I ask that you would help them to be focused and attentive and to apply themselves diligently to everything that they find set before them, Father, so that at the end of the day we can honor you and glorify you in all that we do. In the name of Jesus I pray. Amen. So, what I am using for my text today is the second edition of Algebra 1. It's published by Bob Jones University Press. It's an old edition. Matter of fact, I'll be transitioning to the third edition next year. Honestly, doesn't matter what edition you're using if you simply want to be able to learn the topics of Algebra 1. Today we're in chapter 1.1, which is called Locating Integers on the Number Line. Doesn't matter what text you use to study about integers, you're going to be getting the same material. If, however, you're trying to use my videos to track along with BJU Press's study of Algebra 1, second edition and third edition are not compatible. The order in there is different, so just be real careful to track along according to the title of the video lesson that I'm doing, rather than the fact that it's chapter 1, section 1, because second edition and third edition do not go together well at all. Before we get started, I've told some of you that I love to start my lessons with a lame joke. I want you guys to bring lame jokes in for me. The way that I judge how successful my lame jokes are is how much I can get you to laugh. And actually not even really laugh, groan. The louder the groan, the lamer the joke, the happier I am. So this is an old one that I'll start the day off with and ask if any of you know what it is that lies on the bottom of the ocean floor and twitches. Well, that would be a nervous wreck. You know, he's lying on the floor just twitching because he's so nervous. Anyway, as I said, we are in section 1.1. We're talking about locating integers on a number line. And a lot of the time when we are in mathematics, specifically when we are in algebra, we're going to find out that if we can use a graph or a number line, sometimes our picture or our understanding of the material that we're talking about is going to be a lot clearer. And it's important that you be able to understand what a number line is and how you use that number line. And we know that everybody knows, who's in this class, knows that we have numbers. 1, 2, 3, 4, 5, 6, 5,000, minus 352, 3.5, negative 2.758342. There are any number of no pun intended, any number of different numbers out there. But there are basically two ways that you can represent a number. A number can be represented in pictures, or a number can be represented symbolically. An example of a way that a number is represented symbolically, if you take that word back, symbolically has the word symbol in it. When you represent a number symbolically, you're just using these characters, you know, the way that you take a pen or a pencil or you draw in the sand or whatever. This is the symbol for the numeral 2, number 3, numeral 4, 234. These are symbols. Another way of representing a number, though, is with a picture of a number. So we're just going to look and see what a picture of a number 3 is. Here we have the symbol. How do you get a picture of number 3? Well, what you do with that is you use a number line to give you a picture representation of number 3. And I'm just going to go ahead and set up this number line here. And this is a new board that I got this year, and it is squeaking like mad. I am so sorry that it's squeaking. I did not think that there was anything worse than the squeak of chalk on a chalkboard. For those of you old enough to remember the chalk on a chalkboard, I think squeaking of a marker on a whiteboard might even be worse than this. But this right here is a picture of number 3. This is a symbol. This is how we draw just the number 3. This right here, that dot on this line, is a picture of number 3. What we have here is the number line. You guys can read in your text. I'm not going to be reading your text to you. I'll teach the material from the text. You read your text, you go ahead and do your homework, you come to class and ask me questions about the homework you've done, and that's how we're going to do this. But we have a number line here. We have drawn a straight line, and you want to use a ruler. Obviously this is not a ruler, it's a yardstick, but you want to use a ruler. You're going to pick a point arbitrarily in the middle of your line, and that's what you're going to call 0. That's sort of the center of your number line. You're going to draw an arrow at both ends of your number line, and that's important because what this arrow means is that this pattern goes on forever. Extends forever, if I can spell. To the right, we have an arrow here at the left that says that this pattern of the number line that we've written extends forever in that direction. When you're drawing a number line, you have to have the arrowheads at the end of the number. If you start here, you see 0, and you go 1, 2, 3, what would be next? 4, 5, 6. So the further you go towards the right on the number line, the bigger the number gets. Okay, and you notice that those are, so I was walking up here to put my marker down, I'm not used to having something to catch this. It extends forever, the numbers get larger, and these are considered positive numbers. Positive numbers. When you move to the left on the number line, -1, -2, -3, -4, -5. What do you think these are called? If these are positive numbers and we have a -1, -2, -3, -4, yeah, these are called negative numbers. If I can spell right again. Negative numbers. Now let's see which is bigger and which is smaller. Let's say that way out here we're going to have a -100. You know, this pattern continues, -3, -4, -5, -6, blah, 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 until you end up with a -100 over here. Which number is bigger? A -100 or a +1? Most of you know that, but if you're not familiar with the concept of negative and positive numbers, you might think, well, this -100 has to be bigger because 100 is bigger than 1. Well, that's true, but let's look at the idea here of negative numbers as thinking about maybe if you owe money, if you owe mom and dad some money. And instead of saying -100, which you don't have a picture of, let's say -3. Which number is bigger, -3 or a +1? Well, what position would you rather be in? Would you rather have $1 in your pocket, which is what we have with +1, or would you prefer to owe mom $3? Well, that's a no-brainer, isn't it? Nobody likes owing money to anybody. Matter of fact, the Bible says, owe no man anything except to love them. So 1 is bigger than a negative 3. So what we're seeing is that the farther you get to the right on a number line in the positive direction, the larger that number is. So the positive numbers, this line extends forever, and these are progressively larger numbers. The further you extend to the left on the number line, once you get past 0, those are called negative numbers. These extend, the number line extends forever, and the numbers get progressively smaller. So negative 1,200 is a smaller number than 2. Negative 1,200 is a smaller number than a negative 1. And whether a number is smaller or larger, you can determine that by looking at a picture of a number line. The further to the left the number is on the number line, the smaller it is. The further to the right that number is on the number line, the larger it is. And I believe in my prayer as I started class, I said, you know, God, we're going to be able to see through our study of math, you know, a part of who you are, a part of your design, and we're even going to see pictures of who God is. A number line just reminds us of who the Lord is, because that number line goes on forever in the right-hand direction, goes on forever in the left-hand direction, just like God just goes on forever. You know, you can't ever really wrap your mind around God. Eternity extends forever. There's no end to the time that we have. Okay, now how are we going to set up this number line that I've written here? I've drawn it for you. I don't think I really need probably to explain it, but when you draw a number line, you draw a straight line. Let me draw one of those again. Just going to draw a short little number line here, which did not mark on that board at all. Straight line. You have to have the arrows at the end of the number line. And the reason you have those arrows is why? It shows us that the pattern, or that these numbers, they don't just stop. You can't count to say, oh, I know what the biggest number is. The biggest number in the world is 32,489,029,207. That's the biggest number in the world. Well, is it? No, it's not. I don't remember how I started that number, but I said 207. Well, what's bigger than that? 208. What's bigger than that? 209. So this number line, there's no highest number you can get, no smallest number you get. So we're going to draw the arrows at the end of the number line. We're going to pick a point on that number line with a mark, and that's going to be 0. 0 is the point on the number line that divides positive numbers from negative numbers. And then when you're drawing a number line on your paper, you're going to use a ruler, and you're going to mark this number line with evenly spaced little marks here. And obviously mine are not evenly spaced because it would take me a long time to be able to divide these spaces up correctly, and it's just not really worth it. So this is just sort of a rough number line. The space from 0 to 1, right here, when you go, that's called 1 unit. This is the distance from 0 on the number line. From 0 to 1, that's 1 unit. From 1 to 2 is a unit. From 2 to 3, and from 3 to 4. And it's important that you understand distance from 0, because we're going to be talking about that when we refer to absolute value just a little bit later in this class. So here we have our number line. When we're drawing it, we're being consistent. You're not going to draw a number line that looks like this. Let me erase all of this. And I'm not going to get that ruler out again, that yardstick out again, but I'm just going to sketch a number line. So I'm going to draw my line, and this marker is just drying out on me really quickly. And I thought, and I tested it before, oh, that's because I had the wrong black one. You know what I do in class? When they run out, I throw them at somebody. So there's a dead marker. And yeah, you're supposed to laugh. So here's a number line, 0, 10, 20, negative 10, negative 20. Do you think that's a number line? Well, it's a straight line, has arrows on the end, it's reasonably divided up, but it says 0, 10, 20 instead of 0, 1, 2, 3. 0, negative 10, negative 20. This is a good example of a number line. You don't have to go by single digits, 1, 2, 3, but you have to use multiples here. 0, 10, 20, what's going to be next? 30, 40, 50. There has to be a pattern that you can relate, that you can repeat. So that would be an okay number line. This right here would also be a correctly drawn out number line. That's a negative 50, not a negative 56, because the pattern is the same. What would be an example of a number line that doesn't work, or something that's not a number line? That would be for you to do 0, 2, 12, 21, negative 1, negative 2. The distance between the lines here has to be the same amount. Remember I said a unit is the distance from 0 to 1. The units here have to be the same. The spacing here has to be the same for it to be a legitimate number line, and for that number line to be a true picture of whatever number it is that we're going to sketch. Now, let me look at this book and see what else I want to say. Positive numbers. Okay. What they're going to ask you to do is they're going to say graph 2 on the number line. Well, what does it mean when it says graph on a number line? It says we want you to give us the picture of number 2 on the number line. Now, is this enough of the number line here that I've written? Yeah, it is. We've got a negative number, we have a positive number, the distance from 0, the spacing is the same, but I'm going to go ahead and add in 1 and negative 1. So when we graph 2 on a number line, this is all you do. You find the location of that number on the number line, and you create your number line, so you do it, and you put a solid dot right at that place on the number line. This is a picture of number 2, and when we are talking about describing what this is, I said, this is the graph of 2 on the number line, and this dot right here, that point, this is called the coordinate of the point of the number 2 on a number line. That's C-O-O-R-D-I-N-A-T-E. This is the coordinate of number 2 graphed on the number line. Now, coordinate is going to be a term that is much more important to you along about chapter 6. But for now, just know this is what it means to graph 2 on the number line, and that's the coordinate. That's really all that there is to know about graphing a number on the number line. Okay, well, this was an easy one to sketch. What if your homework problem says graph 25 on a number line? I have had kids do this. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. 1, 2, 3, 4, 5. My hand's tired. 25, negative 1, 2, 3, 4. You see exactly where I'm going with this picture, don't you? And then they put their dot right there. The coordinate, they graph the coordinate of 25 on the number line. Is this correct and true? Absolutely. But there's no reason in the world for you to graph it like that. I don't want you to. And while it is a true graph, it's not the best thing to do. How would you count by 25s? 25, 50, 75, 100. Pick your 0. 25. Do another, identify another hash mark on that number line so that everyone clearly sees your pattern. Negative 25, negative 50. Indicate with a solid dot the coordinate of the point 25. Both of these represent the graph of 25 on the number line. This is the way that you need to do it. This, while it's technically correct, is not a realistic way to use it, not a realistic way to do it. It's cumbersome, it's easy to get confused. This gives you a very clear, concise picture and helps us to see exactly what we're talking about. All right? If you're looking on your book, second edition of Algebra 1, I flipped over to page 4. Something that I want to go back and talk about. What direction is this line going? Yes, going across, back and forth, but is that a horizontal line or is it a vertical line? Okay, this is a horizontal number line. 0, 1, 2, negative 1, negative 2. So this is a horizontal number line. Really hard definition right there. It's a line that's running horizontally that looks like a number line. It's a horizontal number line. So what do you think? Oh, that squeak is awful. What do you think this is called? Does it look like a number line? Well, if you sort of stand sideways, it looks like a number line, sort of maybe. Is it horizontal? No. What is it when it's straight up and down like that? It's a vertical number line. Vertical number line. Now let's think of some real-world examples. What's an example of a horizontal number line? You already saw me use that. It's my yardstick. That's a horizontal number line because you read the numbers very obviously here. If I stand it up like this, it's a vertical number line, but you still have to read, turn your head sideways to read these numbers. Who can you think of an example of a vertical number line? Matter of fact, I have one right over here. This was my grandfather's. It's a combination barometer and thermometer. The barometer is at the bottom. It talks about air pressure, which has nothing to do with this course. However, we've got this little thermometer here. And as soon as I said thermometer, you thought, oh yeah, I see those all the times. The only thing that a thermometer is, it's a vertical number line. We're here in Texas. It is nearly September. It is going to be a particularly warm day. Here's my fancy thermometer that I've drawn. Now, those of you who've had me before, you know drawing is not my gifting, but we're just going to work with me. So let's say that we have, here is 0 degrees, 25, 50, 25, 50, 75 degrees, and 100 degrees. It's nearly September. The forecast temperature for today is 102 degrees. So if we wanted to graph 102 degrees on our vertical number line, what would this thermometer look like? Well, all of this here would be filled in. So a thermometer is nothing more than a vertical number line. So in your problems, when it says graph 10 on a vertical number line, they want you to draw the line, number line, label it similarly to this, put a solid dot at the coordinate of 10. And this is how you graph 10 on a number line. See? Totally simple. And you thought that algebra was going to be so hard. Well, the way that this particular text works, Bob Jones' algebra text works, and the way that the vast majority of them work in public school, every text that I've seen, you know, kids take the summer off, they haven't been working with material, they've put out of their head all of that material they had to learn. So for the first part of time, several chapters, there's a lot of review to sort of ease you back into the idea of getting your brain working, you know, dusting all of those cobwebs out of there so that you can do the manipulations with your numbers that you need to. So this is just a review of arithmetic and of pre-algebra that we're going to be doing for quite a while. So nothing to be afraid of, and by the time you really get into solid Algebra 1, if you've been diligent to do your work, you're going to be so totally prepared for it. So let's go back to this horizontal number line. Like I said, on a horizontal number line, right is always positive, left is always negative. Think back and picture that thermometer in your mind. The top is positive, negative is at the bottom. That's what a vertical number line always is. Towards the top is positive, towards the bottom is negative on a number line. And I want to read something to you. I'm going to rarely read to you. I hate to be read to myself. I find it boring and not helpful. I trust all of you to be able to read your text. It says this is on the top of page 4, the third paragraph down. Two numbers, when plotted on the same number line, define a segment. The coordinate of the midpoint of this segment can be found by averaging the coordinates of the endpoint. For example, the midpoint between 4 and 10 is found by averaging 4 and 10. And you go, what in the world does that say? So let me go ahead and plot the points that they are talking about here. I'm going to extend my number line on out a little bit. I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2, 3, 4, 5, 6, 7, 8, 9, and 10. And they're talking about point 4, and they're talking about point 10. And you may or may not know this terminology. There's something that's called a line segment. And a line segment is a piece of a line. In the math world, a line extends forever in two directions. Like a number line right here, this is a picture of a line, but it never has a beginning. God has no beginning. The number line never ends, just like God is not ever going to end. But in the real world, we don't deal with number lines. We deal with little pieces of that number line, like a piece of spaghetti, or a ruler, or a straw, or a pencil. And a little piece of that line is what they call a line segment. When you have two numbers graphed on a number line, they're the two ends of a line segment. And there's a way that you figure out where the middle of that line segment is. It's what they call the midpoint. let's look at my yardstick right here. You know that a yardstick begins with 1, ends with 36. The middle of that yardstick is 18. Now that's the balancing point. It's what they call the midpoint, or the middle of this yardstick. The midpoint of two numbers on a number line is found by adding together the coordinates of the 2 points and dividing it in half. So the coordinate of the first point plus the coordinate of the second point, we're going to add together, and then we're going to divide it by 2. The midpoint is equal to 4 plus 10, which is 14, divided by 2. 14 divided by 2 is 7. So this tells us that the middle of this line segment right here, that starts at 4, ends at 10, that midpoint is right there at 7. And what is the midpoint? The midpoint is the middle of a segment. It's a point where if you could balance it physically, you're going to have the same length on either side of that balancing point, on either side of this midpoint. Is this true here? Well, let's see how many units it is from 7 to 10. From 7 to 8 is 1. From 8 to 9 is 2. From 9 to 10 is 3. So you have 3 units in the positive direction from 7 on the number line. How about in that negative direction? 7 back to 6 is 1, back to 5 is 2, and back to 4 is 3 units. So you have 3 units in the negative direction on the number line. So 7 is the midpoint of that line segment because it's balanced. You have the same distance to the end, both going in the positive direction, going in the negative direction. So that's all that they're asking you, is what's the midpoint of a line segment that begins at 4 and ends at 10. Let me go ahead and pick a number from our homework problems, and let's go ahead and do one that has to do with midpoint. I think it'll be very, very close to you. Very, very easy for you to understand, rather. So I'm on page 5, exercise B, number 20. This says, find the midpoint M of the segment defined by each pair of numbers. So this is number 20. We have a pair of numbers 12 and, I think I said 20, we're just going to say 12 and 22. Find the midpoint. My hand cannot go as fast as my brain thinks or as fast as my hand writes. So sometimes I get ahead of myself. Find the midpoint of a line segment, a piece of that number line that starts at 12 and ends at 22. Now you don't have to draw the sketch, and I don't expect you to. This is just a rough sketch of what they're talking about here. They want to have a point on the number line, begins at 12, ends at 22. That's a line segment. What is the coordinate of the point that's halfway between 12 and 22? It's what they call the midpoint. The midpoint is equal to the coordinate of the first point, which is 12, plus the coordinate of the second point, which is 22. And then you cut that in half, divided by 2. The midpoint is equal to 34 divided by 2. When you do that division, you discover that the midpoint of that line segment is 17. Midpoint is 17, right there. And if you had drawn this number line out so there's a a single marking between 12 and 17, 17 and 22, 17, 18, 19, 20, you'd see that it's 5 units from 17 back to 12, 5 units from 17 up to 22. So the midpoint of these two numbers is 17. Now some of you are looking at this and saying, what in the world is that? There's a slash on your 7. I need to tell you that, I don't know where my black pen is, I need to tell you that this is how you tell between, this is how I'm going to write a 7. This is how I'm going to write a Z, and this is how I write a number 2. 2's can sort of look like my Z's, or Z's can look like 2's, so I'm going to put a slash through a Z. I'm also going to put a slash through my 7. And when I write variables, when I'm talking about X, this is what X is going to look like. Just some little tips to remember about my handwriting. And that's all that there is for section 1.1. I know that I went on a really long time. If you're still hanging in here with me, thanks for being there. Moms, dads, if your kids understand the material, there's never a reason to make them sit through an entire video just so that they can check off, oh yes, I listened to the entire video. Okay, you use these videos as a tool to help your kids understand the material, as a tool for you to help teach to them, or even learn something or relearn something for yourself. I am not tracking how many times each student gets on the computer, how long they watch the videos. I have no way of even knowing that. These videos are out here simply as a tool for you. Thank you for the privilege of teaching your kids, and I'll see you next time.